So a quick agenda to run through, just going to give an overview of some of the different applications that we've been using StreetLight for. I'm going to focus on intersection turning movement volumes, the trip length information that we've been taking from StreetLight for use in some of our VMT analyses for both policy setting and project level analyses, and then take a look at some cut-through traffic analyses that we just are beginning to take a look at using StreetLight. And I'll close out with some takeaways from our uses. So just in general, Kimley-Horn is a nationwide firm, and we've been using it throughout the country. And then our team has been using it in California since about 2017. We're using it for a wide range of analyses, origin destination analyses, roadway segment analyses, traffic counts, both intersections, roadway segments, etc., corridor analyses, and then model calibration and validation data. Then, as I mentioned, the focus today is going to be on the intersection turning movement counts, that trip length information, and then the new top routes feature that we're looking at to help analyze cut-through traffic. We at Kimley-Horn got together and ended up putting together a white paper on how best to use or what intersection turning movement counts to use when projects come up during COVID times. I know the traffic volumes are getting a little bit more back to normal, but we're still not there yet. And so a lot of jurisdictions have a stipulation that when you collect traffic counts, you want to have normal day conditions. And there's been a lot of talk about a new normal, but you know, we're still working with a lot of folks who want to see what conditions were like pre-pandemic. And if there are no historical counts, you know, we're looking at StreetLight has been a great addition to our toolbox in terms of developing those volumes. So the white paper was actually cited by ITE's white paper that they're putting out. I put a link to it if you want to read more. But there is we put together a decision tree that I'm going to talk about in more detail in the next slide. But just in terms of how it works in general is we're looking at origin destination data at the hourly level from the different intersection approaches to help determine individual volumes for different movements. So this is the decision tree that we've kind of put together. I've boxed the area where it ends up with using StreetLight data. So it's not the only solution. You know, there are certain conditions when you can still use some of that historical turning movement count. But there are a few conditions where StreetLight has been extremely helpful in some of our analyses. Let's focus on that right now. So really where you're looking at using it is intersections where you don't have historical counts, or those historical counts tend to be 5 or more years old. And then there are 2 options in terms of calibrating the data. You know, as Eric mentioned, when you do have roadway segment data nearby, you can help use that to calibrate the data. But we have found that even without calibration, the StreetLight data is coming back very solid and has helped us on numerous projects throughout California. So just wanted to show a little bit about what the interface looks like when you're in the StreetLight portal. You know, you do get to download this information to help use in your actual analyses, but just at this 4-way intersection, you can see the 4 zones, and then we're using the origin destination data from each zone to each zone to help develop those turning movement volumes to use in the technical analysis. You know, we tend to use October 2019 as our go-to normal day time, which allows us to use multiple days throughout the month to help better increase the validity of the volumes. And what you're looking at now is you know, the 7 to 8 a.m. time period, so kind of that AM peak hour that we're using. So now I'm going to talk about how we're using StreetLight and big data for helping with our VMT analyses and both developing policies and project level analysis. My focus today is going to be on using the 3-county model for SJCOG, STANCOG, and MCAG. We've used it on a variety of different models, but as this focuses on Central Valley, we're going to talk about the Central Valley test case. I just wanted to mention that, travel demand models are extremely useful tools, but can end up, when used for VMT analysis, it can end up with more variation than expected. Travel demand models weren't exactly designed to help determine VMT thresholds for different jurisdictions. And so combining model data with StreetLight data has helped improve the results in both smoothing the performance and results across zones, and then just increasing that reasonableness of the results. Without it, we have seen instances where TAZs across the street from each other are resulting in vastly different results, which doesn't exactly lead to a logical conclusion. And so combining that StreetLight data with it has helped produce results that we're looking at and are a lot more reasonable. So in developing the kind of what we're looking at in terms of VMT methodology, we have 6 different approaches that we did end up looking at and continue to settle on. One is just using the model as is, or using StreetLight data as is, using StreetLight average trip length only, using LEHD data, and then using 2 different combinations of model outputs and StreetLight data, which is what we're leaning towards. So just to go into a bit more detail on that, you can kind of see the positives and negatives that we're kind of touched on a little bit. On the right-hand side are the 2 different types of combinations where we're using model data and StreetLight data to help determine, setting those VMT thresholds. So just wanted to show there are several different options that come with it, but we've really found the best results come with combining StreetLight and model outputs. And we're using this methodology to help develop a tool that's going to automate this process to make it a lot easier for users without having to deal with all the data and different models and things like that. So just a point to touch on, when combining this data, you do have to do a bit of post-processing because TAZ boundaries and census blocks, which is what we are using, don't exactly align. You can see the TAZs are a lot more disaggregated here. So having to combine those together to use their data combined with the StreetLight data is one thing, but you'll also notice some of the census block boundaries don't exactly align with the TAZ boundaries. So having to deal with that is one challenge that we came up with. But as I mentioned, StreetLight has really improved our results, and so it's just a small blip on the road to getting those great results. And then again, I wanted to provide a visual representation of what this data looks like. Again, you can download all of this data to help use in your analysis, but this is just a visual representation of a point where we're looking at both the number of trips and the length of those trips to help provide a weighted average by census block to determine that trip length for use in our VMT analyses. So I wanted to close out with the top routes feature that we've just started exploring. And this is another StreetLight application that we can use in combination with travel demand models. Right now, we're looking at, currently today on congested freeways. I think that's a problem we're seeing throughout California. But just, when we're in those peak commute periods and vehicles are looking to find alternate routes to try and avoid some of the most congested spots, what are those routes? And for jurisdictions that are looking to keep vehicles on the freeways and off those local roads, what features can we put there to kind of divert those vehicles, and how will the travel behavior respond to those? And so that's what I'm talking about when we're talking about combining the 2 different, both StreetLight and models together. So we're using the model to help define the response that vehicles have to introducing the new transportation facilities or trip diversion, but using StreetLight to help understand what's happening today on the ground. And so, this is just a quick visual representation showing the different routes where, red is heavier volume and green is the lighter volume. So you can really see between the blue dots are the origin and the purple are the destination that, there are several routes that do avoid the freeway. And so this is what we're just starting to explore to help better understand, what things we can put in place to try and keep those folks on the freeway and off the local roads. So just wanted to close out with some takeaways. As I mentioned, StreetLight has really solved a need during the pandemic in a variety of areas. And, being able to combine StreetLight with travel demand models, have helped improve our VMT analyses, allows us to maintain that forecasting effect when using them in combination. And just, as more and more complex problems arrive, using that on the ground data combined with the other tools that we historically use has really been helpful in answering those questions. And just another takeaway we found when interacting with the public, but using big data and StreetLight to help, really understand what's going on today rather than trying to rely on, snapshots of historical data or surveys has really increased the confidence with our results, when we're sharing these analyses with the public.